Now we're going to look at the graph of our tangent function. So if we want to look at y equals tangent of x, and we go to the calculator, let's clear out what we had in before. So we have a tangent key, so we can simply type in the tangent of x. And once again, I want to go to zoom 7, which is zoom trig. And now here you'll see the graph of our tangent. And this one is a little different from our sine, cosine, and secant and cosecant. And hopefully now what you'll notice here with this graph, from looking at it, can you determine what the period is for this graph? And once again, realize we're going from 0 to 2 pi based on our scaling. So then here this would be pi over 2 pi, whoops, let's see, 0 to pi over 2 pi and 3 pi over 2. So notice what's going to be the period here, and of course it may be easier if we go back here and actually look, and this would be at a negative pi over 2. You're also going to notice here, just like the secant and cosecant function, we end up with some vertical asymptotes right here at negative pi over 2, positive pi over 2, and 3 pi over 2, and over here at a negative 3 pi over 2. And the reason that we're going to end up with vertical asymptotes, you probably can guess, is we're going to have some point division by 0. So how does that happen? Well, I guess before we get to that, let's look here. I mentioned something about the period and forgot to continue here. If we notice, if we go from negative pi over 2 to a positive pi over 2, and if we look at this part of our graph right in here, what happens once we go from negative pi over 2 to pi over 2, then the graph starts to repeat itself. So we're going to notice here that the period, negative pi over 2 to pi over 2, the period for just your standard tangent function is going to be equal to pi. Okay, so that's half of the period of what we had for the sine and cosine functions, where the period was equal to 2 pi. So you have to realize the tangent function is going to repeat after a shorter period, in this case, of simply pi. And why is that the case? Well, once again, go back to the unit circle. If we start here at 0 and we go around, and we have to recall here, if we have our coordinates of each of these 4 or 5 key points here, we will notice that for our tangent function, what we have to really recall is when we say y equals tangent x, remember tangent is the same thing. If we think of our quotient identity, that's the same thing as sine x over, whoops, not the tangent, the sine over the cosine of x. So what we have to be aware of is, where is the cosine? 0. Well, cosine is our x value. So if we look around here at our x coordinates, here we have a 1. Up here at pi over 2, notice our x value is 0. And that's why over here at pi over 2 on the graph, we have a split. And then we notice at 3 pi over 2, our x coordinate here is also a 0. So that's why we have a vertical asymptote at 3 pi over 2. Or I'm sorry, we had positive pi over 2, also a negative pi over 2, and a negative 3 pi over 2. So that's where the vertical asymptotes are coming from, because the cosine function is going to be equal to 0, so therefore we have 0 in the denominator, so that makes it undefined. So similar to our sine function and cosine, if you remember, we looked at the example of y equals a sine of, let's see, what did we have here? Bx, y equals a sine of bx minus c plus d. If you remember how we talked about the different transformations here, that this uh, affecting the a, the b, and c, or the bx minus c was the phase shift. The b, 2 pi over b was the period, a was the amplitude, and d was shifting the graph up or down. Well, we're going to kind of have the similar thing here for our tangent function, where we have y equals a tangent of bx minus c plus d. Now, once again here, we don't really have an amplitude, so the a part of it's not going to really affect here. We wouldn't really have the amplitude because that's telling us with the sine and cosine how high and how low the graph is oscillating between here. But we do know that if we're trying to calculate the particular period, and this is one thing you have to be careful with for the tangent function. If we're going to calculate the period, keep in mind we said that the period up here was equal to 1 pi. So with the sine function, remember over here, we took 2 pi over our b value. Okay, that was when we were looking at the sine and cosine. But over here, because the period for the tangent is pi, it's going to be simply pi over the coefficient of x, which is pi over b. And just like we had with the sine function, remember we talked about having a starting of one period. Well, we could do the same thing here with the bx minus c. And recall over here we took bx minus c and we set that equal to 0, or we took bx minus c and set it equal to 2 pi for the start of one period, and then the other one would give us the end. And all we had to do was solve the equation here for x. So hopefully you recall doing that with our sine and cosine functions. But if we notice up here, before we look at this start point, we're going to take bx minus c, and notice we're not going to set it equal to 0, because if we go up here and look at the graph here, and I'm going to look at the portion of the graph right here that goes through the origin, it's going from negative pi over 2 to a positive pi over 2. So to find actually one start here, typically what you're going to do is you're going to take the bx minus c and set that equal to a negative pi over 2, and we're going to kind of focus on what's happening to this part here. Which way is it going to move? Okay, and then if we want to look at finding the end, we would take the end point of one cycle. You would take bx minus c, set that equal to a positive pi over 2. So we're kind of figuring out how is this shifting with relationship to the negative pi over 2 and the positive pi over 2, just like we did over here with our sine and cosine, but we were basing it off of 0 and 2 pi. So let's look at an example of using this. If we had the equation y equals the tangent of x plus pi over 2, and if we want to calculate the period, okay, well, we would look here and we could say, all right, well, the coefficient of the x here is 1, so that would be pi over 1, so the period would simply be equal to 1 pi. And if we wanted to find the start of a period, now again, of course, you could pick anything here, but if we wanted to find a particular starting point, we would take that bx minus c and set that equal to a negative pi over 2. So in this case, we would have x plus pi over 2, set that equal to a negative pi over 2. And if we solve for x, we're going to subtract the pi over 2 over here. So negative pi over 2 minus pi over 2, we would end up with a negative 2 pi over 2, or we would simply have a negative pi. And then, of course, if we wanted to, just for kind of verification, if we want to calculate the end, we would take the same thing of x plus pi over 2 and set that equal to a positive pi over 2, and then x would be equal to, if we subtract pi over 2 minus pi over 2, we end up with x equals 0. So let's see if that's the case. Well, we said the period was 1 pi, And if we look at the graph, we'll go to the calculator, and we want to type in the tangent of x plus pi over 2. And if we go to the graph, notice now with the tangent, the graph actually went through the origin, but now there is no part of the graph that's going through the origin, and that's because we have that phase shift in the graph. And if we look here closely, we can see what's happening. Where the graph normally went from negative pi over 2 to a positive pi over 2, if we think of this as starting at negative pi, what we've looked at now is we moved everything to the left. So if we look here at negative pi, that would be here. And if we look at x equals 0, that is now here. So we're getting this part of the graph, which is exactly 1 period. And of course, what's happening here is if this is at 0 and this is located here at negative pi, then we know that from 0 to negative pi, if we were to cut that in half, that would tell us that this part of the graph here then would be a negative pi over 2, because this point where it crosses the graph is going to be in the middle from this starting and end point for 1 period. So if the period is pi, then half of that is going to give us the midpoint, which is where the graph is going to cross through the x-axis. So again, similar to the other graphs, in this case we're looking at the tangent. Now again, at negative pi and here at 0 we have the vertical asymptotes occurring because we would have the division by 0. So the one thing you have to remember here when you're looking at the tangent function, I want to really emphasize the fact here that the period up here is 1 pi, and if you're looking at kind of the start and the end of one particular period, we're going to set this equal to a negative pi over 2 and a positive pi over 2, as opposed to what we did over here before using 0 and 2 pi for the sine function. So that means when you're calculating the period of the tangent, instead of 2 pi over b, we're going to be using pi over b to actually calculate the period of your tangent function. And again, the b value is simply the coefficient of our x.